So good evening, anyone, to this class, which is where we are going to start the next topic, which is refraction. We had dealt with the reflection, which is what is coming in your exam tomorrow. And in this class, we will start with the next thing, which is much bigger than the reflection wala part. This is the major part of this particular chapter, refraction. Before going into refraction, I hope you know what is refraction. Can anyone tell me the definition of refraction? Anyone who has a mic and who can speak? What do you mean by refraction? What do you understand when you hear the term refraction? I guess everyone knows what is refraction. Can you just tell me, throw some light onto it so that I can see clearly what do we understand by refraction? Yes, I guess everyone, I am audible and visible to all of you. Please tell me, what do you mean by refraction? I can see raised hands at the last bench. What do you understand by refraction? Raised hand is not telling me anything about refraction. Mic is not working. Sad day for democracy in India. You've got the right to speak, but the mic doesn't work. Is that so? The other class, the mic works, but we get this humming sound, right? And to unmute, you have to go up, I think. Yes.
Bending of light from one medium to another medium.
Bending of?
Light from one medium to another medium.
Bending of light from one medium to other medium. What does it mean is, let me just open this so that I can unmute you when I feel like, so that the voice quality is better. Now, let us take the very first example and see how did we start and where we are. This is what? This is boundary between two mediums. On this side, we have medium number 1. On the other side, we have medium number 2. The best example is the surface of lake. Above the lake, you have air. Below the water surface is definitely water. So the surface of lake is a boundary between two mediums. That is what I have drawn by the horizontal line. The horizontal line is the boundary between two mediums. Now, whenever a ray of light, and I don't know why I can't draw a straight line, whenever a ray of light strikes a boundary between two mediums, I hope everyone understands what is I and what is N. Yes or no? I stands for the incident ray. Yes or no? We understand this? I hope you understand this. You don't have to say it. We have already gone through. So I stands for the incident ray, and this incident ray is hitting this boundary between the two mediums. Now, in the chapter on refraction, we had not probably set boundary between two mediums. We had said that it hits a plane mirror or a curved mirror or whatever. We can extend the definition to boundary between two mediums. A part of this light is going to be traveling back into this medium, the same medium from which the incident light came. A part of the light is going to go back, and this is the angle of reflection, and this is known as the reflected light. So far, so good. Please raise your hands. We know angle I is angle R, and I, R, and N all lie in the same plane. That was a law of reflection. It goes back in the same medium. But a part of it will be going back, will be going into the next medium, which is medium number 2. So whenever a ray of light travels from one medium, the first medium where you have incident ray is known as medium 1. The second medium is known as medium 2. Whenever it goes from medium 1 to medium 2, it bends. It bends. Let me call this as since R stands for reflection, R also stands for refraction, I call it as T. T stands for transmission. So it is transmitted. Do you understand the meaning of transmission? Transmission is same as refraction. The ray of light has gone from one medium to the other medium. Instead of calling it as refraction, I can also call it as transmission. Though this is hardly used for ray of light, but you might have heard this term in thermodynamics. I'll come to that. So it bends. Now, what do you mean by bending? Is that if you just trace the original ray, and let us say this is the original ray, my line may not be straight, but this is the straight line that I have drawn. This is the original path. Do we understand this? This hash is the original path of the light. If there was no boundary, the light would have gone like this. But because of change in medium, instead of going along the hash line, it may go along the maroon path, whatever path is this. I'm very bad with colors. Or it may go like this along the red path. Again, I call that angle as T. So the maroon path is where I say why I use the different color. The maroon path is when I say that it has bent towards the normal. Do we understand this? This light ray has bent towards the normal, and the red wala light ray has bent away from the normal. So whenever light travels from one medium to the other medium, it cannot go on the same straight line path. It will bend. Either it will bend towards the normal, as this one, whatever the color is, purple or whatever it is, or it may bend away from the normal. This bending of light ray when it travels from one medium to the other medium is known as refraction. Do we all understand this? Bending of light rays as it travels from one medium to other medium, and that is what you will write. Bending of light rays. Bending of light rays as it travels from one medium to other medium is known as refraction. Do you understand this? This is the same definition that you might have read in your earlier classes, may it be your 8th standard or 10th standard. Remember, whatever you have done in 10th standard, the same thing we are going to do in your 12th standard. Bending of light rays as it travels from one medium to other medium is known as refraction. The same definition is valid. The question that I'm going to ask, and which you already must know, why does it happen? Why? And there's a big question mark here. Why does light bend? Why it should bend when it goes from one medium to other medium? Tell me. Tell me, why does it bend? Anyone?
Due to refractive index.
Yes. The camera is off. What happened? I hope everyone can see me. Why does it bend? Why does light bend? When light moves from one medium to another medium.
Change in medium.
Change in medium. But what happens because of the change in medium? Obviously, if it was moving in the same medium, nothing would have happened. What has changed because of change in medium?
Speed of light changes.
Yes. It bends because the speed of the light changes. And the reason is speed of light is different in different mediums. Speed of light is different in different mediums. because of speed of light being different in different mediums. When it travels from one medium to the other medium, the speed of the light changes. Because of this change in the speed of light, it will bend, and this phenomena is known as refraction. Do you all understand this? Can I have some reason that we understand this? Do you understand this?
Hello.
Yes, beta.
Are we audible, sir?
Are you audible? I should be asking you this question. Am I audible?
Yes, sir.
You are also audible. So, do we understand this, beta? Everyone can see me. Everyone can hear me.
Yes, sir.
Okay. The other class camera has gone off. So, because of the difference in the speed of light from one medium to another medium, when light moves from one medium to other medium, the speed of the light changes, and because of this change in the speed of light, it will bend. Now, what all things change when the medium changes? So let us write it here. We must know this formula. V is equal to F lambda, yes or no? We know this formula. V is equal to F lambda, where V stands for the speed of the wave, F stands for the frequency, and lambda stands for the time. Lambda stands for the wavelength. Do we understand this? Yes or no?
Yes, sir.
Now, in this F, this frequency depends on the source. This frequency of the wave or the light ray, it depends on the source, and it always remains same unless you change the source of light. For example, this LED bulb will give me a different frequency of light. Some other bulb may give me a different frequency. The frequency of light always remains same whether you change the medium or not. The frequency remains same. Do we understand this?
Yes, sir.
When light travels from one medium to other medium, what changes? Is what we have seen. The speed changes. Yes or no?
Yes, sir.
Now speed changing, but frequency remains same. That means what happens with the wavelength of light? Does it remain same or does it change?
Changes.
It will also change. So instead of calling it as speed changing, you can also call it the wavelength of the light changes and it moves from one medium to the other medium. Or I can say V is directly proportional to lambda. Everyone understands this. If V increases, lambda increases. If V decreases, lambda decreases. Yes or no?
Yes, sir.
Because of this change in the speed of light, as it moves from one medium to other medium, the light bends. Sometimes it bends towards, sometimes it bends away. You will understand when will it bend towards and when will it bend away. But let us now move on to this phenomena of different speed of light in different mediums. Now, since the speed of light is different in different mediums, we have two types of mediums: rarer medium and denser medium. Now, this which medium is denser and which medium is rarer, it again depends on your reference. If you take one medium as the reference, the other medium may be rarer or the other medium may be denser. Rarer or denser medium depends on the speed of light. If the speed of light is more, then we call it what medium?
Errors.
Yes, and that is what you will write because you might get confused in all these points. So you will write it. Point number one, if the speed of light is more, if V, speed of light is more, medium is known as rarer medium. Point number two, if speed of light in the medium is less, less speed, that means the medium is dense. It's very hard to move. That's how I remember it. The medium is called as the denser medium. Do we understand this? Yes or no? Very
Yes, sir.
simple things. And you can understand them logically. Now, in which medium is the speed of light fastest or the most or the greatest? In which medium is the speed of light fastest? Or
Vacuum
in
or air.
Okay. Speed of light. It's fastest in vacuum actually, but in air also, in our atmosphere also, it is almost same. Speed of light is fastest in vacuum or air. Therefore, vacuum or air, they are known as the rarest medium. Do we understand this? No medium is more rarer than air or vacuum. Air or vacuum is known as the rarest medium. It's not the rarest material or rarest compound or metal. Is the rarest medium simply means that the speed of light is the most, or it is fastest. And this speed of light in the rarest medium is known as c. So whenever you use the term c, that is basically used for speed of light in vacuum or air. And everyone knows the value of c. Yes or no?
Yes, sir. 3 into 10 power 8 meter per second.
3 into 10 to the power 8 meters per second. No one can go faster than the speed of light. In fact, you can't even go till the speed of light, because then something else will happen. Now, to understand this rarer and denser medium in a more good way, we have coined this term, and that term is known as, someone said this term before, and that term is known as
Refractive index.
refractive index, denoted by the letter mu. Refractive index is the term that tells us how rarer or how denser this medium is. Refractive index tells us that. Now, this refractive index, now whenever we have a term or a unit, we must have a reference. For example, if someone tells us the length of this pen is 10 centimeters, the reference is centimeter. You understand centimeter? If you know how
Yes,
much
sir.
is 1 centimeter, you can find out how much is 10 centimeter. Similarly, if we are talking about the masses of atom, they are very, very less. Therefore, we have this unit of mass, which is known as AMU. Do you know AMU? Yes or no?
Yes, sir.
Similarly, when we want to compare how rarer or denser medium are, which is a rarer medium, which is a denser medium, we need a reference from where you can compare it. And the reference is taken as refractive index of air or vacuum. And the refractive index of air or vacuum, what is the refractive index of air or vacuum? Refractive index
1,
of
sir.
or vacuum is taken as 1. Do we understand this? Everyone knows this. I'm just going through this. Refractive index of air or vacuum is taken as 1. Now, once we know how much is 1, the refractive index of air is 1, then we can find out the refractive index of any medium with respect to air. That refractive index is known as the absolute refractive index of the medium. Do you understand this? Absolute refractive index of the medium. Do you understand this?
Sir.
Absolute refractive index of a medium. How we define the absolute refractive index of the medium? You write it like this: mu of the medium with respect to air or vacuum. Mu m, and a is written on top. Do you understand this? Or simply
Yes, sir.
you can call it mu, or you can call it mu of medium. Whenever you are writing like this, it means the absolute refractive index of the medium, which is nothing but the refractive index of the medium with respect to air. And can you tell me how do we find this out?
Velocity of light by vacuum.
Velocity of light by vacuum.
Speed of light in air by speed of light in vacuum.
Speed of light in air by speed of light in vacuum, that is 1:1. Answer is 1 in all cases.
Speed of the light in air by speed of the light in medium.
Yes, now you are talking. It is C by V or C by Vm, where V or Vm stands for the speed of light in the medium, and C stands for the speed of light in vacuum. Do we understand this? Speed of light in vacuum divided by speed of light in the medium. That ratio, remember, it's a ratio, it's a ratio, it's a ratio. It's a simple number because it is a division of two physical quantities which are same. Velocity, speed of air, speed of light in vacuum divided by speed of light in medium. Do you all understand this? That is known as the refractive index of medium, or absolute refractive index, or refractive index of medium with respect to air. Now remember, important terms, important thing, important terms. Remember, this C is always greater than the speed of light in the medium because light is fastest in vacuum. Yes or no? No, yes.
Yes, sir.
This implies that the refractive index of the medium or refractive index of the medium with respect to air or vacuum will always be greater than 1. Do we all understand this? Please raise your hand so that I know that we understand this. The value of mu will always be greater than 1 because C is always greater than Vm. Yes or no? No, yes.
Yes, sir.
This is the absolute refractive index of a medium with respect to air. But sometimes we may also find out, my dear friends, a term which is known as relative refractive index, and I'll give you a chance to tell me what would be the relative refractive index of a medium. So I write relative refractive index of one medium with respect to the other medium or the second medium. Yes, tell me, bacha. And we might encounter this term many times, my dear friends. Relative refractive index of one medium with respect to other. How do I write it? I write it like this: mu of 2 with respect to 1. Do we understand this? Second medium with respect to the first medium. And how do I write it? I can write it as mu of 2 divided by mu of 1. This mu of 2 is the absolute refractive index, which is the refractive index with respect to vacuum, divided by mu 1, which is the absolute refractive index of the first medium. Do we understand this? Yes or no? No, yes. Please raise your hands and tell me, yes sir, yes sir. No sir, no sir. You understand this, sir?
Yes, sir.
Okay, now I can have one more formula for this mu 2 by mu 1, which is refractive index of 2 with respect to 1. Can I have that formula? Yes, I'm waiting. In terms of speed of lights, you know the original formula, my dear friends?
Sin of I by sin of R.
Ah? Sign? Where did sign come? Huh? Open your eyes and see the
V1
wonderful
by
video.
V2.
Yes. Say it again. V1 by V2. If that is what you said, congratulations, my dear friend. This is absolutely correct. What does V1 and V2 stand for here, bacha? Huh? What does V1 and V2 stand for?
Velocity of light in medium 1.
V1 stands for velocity of light in medium 1. Well done. V2?
Velocity of light in medium 2.
Shabash. That is absolutely correct. Do you all understand this? Can I have some raise hands from everyone? That we have understood the value of, the meaning of mu 2 by mu 1 or mu of 2 with respect to 1. Can I now make more formulas for this? And remember, this chapter is all about remembering things. The more the relations that you can remember, my dear friends, the better you are going to perform in the main exam. So now I have mu 2 by mu 1, which is nothing but, my dear friends, mu of 2 with respect to 1. And I've written it like V1 by V2. Can I write it in a different form also? Instead of using velocity v1 and v2, can I use something else which we already discussed and I showed it to you? And that is how I'll know how much attentive you have been in the class. Now everyone is looking at their faces. Remember, the answer of the question is not in the faces of your compatriots or your companions or your friends. It's in the book. Yes. No one knows it? Shameful.
Lambda 1 by lambda 2.
That is correct. So God exists. So you are paying attention, and that is good. We can write it as lambda 1 by lambda 2 because V1 is F lambda 1, V2 is F lambda 2. F does not change. Frequency of light does not change. It only depends on the source. We have not changed the source. It's only moving from one medium to other medium. So now I have this revolutionary formula number 1, 2, 3, 4. I don't know what you call them. Do we understand this? Yes or no? Raise hands will give me more confidence that we are on the same universe where I am taking the class and you are ending it. Okay. Now see, same thing. Yes, bacha? Say. Someone was saying something? Yes?
Nothing, sir.
Nothing, sir. Okay, sir. Now, see, remember, simple things makes a lot of a difference. This is one way of remembering it. If you can remember it in different ways, you will save a lot of time in the examination hall. And this is how the questions in JEE, and one of the most difficult question ever to come in JEE was from this particular aspect that I'm going to now write. Now, we understand this yellow equation, which I'm again coloring yellow. But now we'll write this yellow equation in just a different way, and you will see how beautiful it looks. That's the beauty of physics, my dear friends. So what do I do here is, I can write mu2 into v2 is equal to mu1 into v1. Yes or no? No, yes. I can write in this form, right? Mu2 into v2, refractive index of medium 2 multiplied by speed of light in velocity, speed of light in the medium 2 is equal to mu1, speed of light in medium, refractive index of light, the refractive index of the medium 1 multiplied by speed of light in that medium. Or I can write mu, oops, I don't have any space, so I'll write it on the second line. Or I can write mu into v is a constant. Do we understand this? A very beautiful way of writing the same thing which was written in terms of fractions. Do we understand this? Yes or no?
Yes, sir.
Now there is one more way of writing it in terms of mu and lambda. Can you write it now? Yes or no? No or yes? I'm waiting.
Mu2 lambda 2 equals to mu1 lambda 1.
That is absolutely correct, my dear friend. Mu2 into lambda 2 is equal to mu1 into lambda 1. Or I can write it again like mu, the refractive index into lambda is a constant. Do we all understand this? Small things make a lot of difference in the eventual question that is going to be asked. Do you understand this? Yes or no?
Yes, sir.
Well done, sir. Rarer, medium will have. Now, we have seen rarer, medium in terms of speed of light. Now, can you again explain rarer, medium in terms of refractive index? If you have two mediums of different refractive index, which medium would be rarer and which medium would be denser? Everything is right in front of your eyes. Rarer medium means medium where speed of light is more. So what about the refractive index? It would be
Less.
less. For rarer mediums, and I'll go back. Go back, 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 go back in time. If V is more, the medium is called rarer, or in place of V is more, I can also write what? Yellow, 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 dirty, dirty fellow. Instead of mu, V is more, what I can write? Mu is what? Less. The medium becomes rarer medium. Do we understand this? The rarest
Yes,
of
sir.
all mediums is air or vacuum whose refractive index is 1. So medium which is closer to 1 is rarer medium because speed of light is more. Medium which has a refractive index much higher compared to 1 is a denser medium where refractive index will be more than 1. So for denser medium, speed of light is less. Green, 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 green. Therefore, mu, the refractive index, is more. Same thing, but said in a different way. I hope everyone understands this. Raise hands will give me more confidence that we are in the same boat, same universe. Yes or no? The third is I can write the same thing in terms of not V or mu, but in terms of lambda. Yes or no?
Yes, sir.
What will be the lambda in a rarer medium, my dear friend? More or less?
More, sir.
So you can write it here. Lambda is more. And still we are talking about the same thing. Yellow, 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 yellow. And for green, I don't have space. So I'll just write it here. Where's the green? Lambda is less. For a denser medium, lambda is less. All these three things refer to the same quantity. Yes or no? No or yes? So everyone understands refractive index now? And you can also find out the refractive index, yes or no?
Yes, sir.
Then I shall give you a question. I hope everyone does it. That will give me confidence that we understood the concept of refractive index. Now, before going to that, onto that question, just remember an important point. Mu of 2 with respect to 1 will be equal to 1 by mu of 1 with respect to 2. Do I need to explain this or is it self-explanatory? Yes or no? No, yes?
Yes, sir.
Mu of 2 with respect to 1 is mu 2 by mu 1. Mu of 1 with respect to 2 is mu 1 by mu 2 and both are inverse of each other. Yes or no?
Yes, sir.
Question. Speed of light in glass, I'm just giving an example, is 2 into 10 raised to the power 8 meter per second. And in water, oh, let's make it ulta. That is better. Speed of light in glass is 1.5 into 10 raised to the power 8 meter per second, and in water is 2 into 10 raised to the power 8 meter per second. Find number A, mu of G. When I write mu of G, what do I mean? Huh? When I write mu of G, what do I mean?
Refractive index of
Refractive index of glass.
With respect to what?
with respect to air.
Air.
With respect to air or vacuum. Well done, my dear friends. Option B, question B, mu of W. Option C, mu GW, whatever it means. Not option D. Question D, mu WG. And you will have 1 minute to show me your talents, or else I will show you mine. And I want all of the students to do the problems on their own. 1 minute is what you get, my dear friends. Utilize it to the best of its use. Do we have answers coming in? Yes, I see some raised hands.
First option is 2, sir.
First option is 2.
Question.
Arey, to tell me na, instead of saying first option is 2, tell
Refractive
me.
index of glass.
That is better, no? Refractive index of glass is 2. Yes, that is correct. What about water?
Refractive index of water is 1.5.
Okay. What about third one?
3/4.
What about fourth one?
0.75.
What about fourth one?
4/3.
Okay, that is great. So I think we have some answers here. Let us solve the question now. Everyone could do this, yes or no? The first one is refractive index of glass, mu of glass, which will be C divided by speed of light in glass. 3 into 10 raised to the power 8 divided by 1.5 into 10 raised to the power 8. And my dear friends, the answer is a sweet little 2. Yes or no? B, refractive index of water with respect to vacuum. Can I have some raise hand from everyone that we understand this? C divided by speed of water, speed of light in water. The answer is 3 into 10 raised to the power 8 divided by 2 into 10 raised to the power 8, and my answer is 3/2. Now there are many ways to calculate mu of glass with respect to water. You can just divide mu of glass by mu of water. You can do it in this way or any other way that you feel like. You will get the same answer. Do we understand this? So in this case, it will be 4/3, I guess. Yes or no? Anyone got this?
3/4, sir.
Nah? 3/4? 4/3. Mu of glass is 2 divided by 3/2 is 4/3. How did you get 3/4? Have you divided ulta? Do we understand this? Yes or no?
Yes, sir.
Pakka na, sir?
Yes, sir.
Doubt na, sir? No na, sir?
No, sir.
Okay. We all make mistakes, but I hope you realize that is why I've done this question, because many a times we will do a stupid mistake and that will cost us a lot more. Now, if I compare glass with water, which is the rarer medium and which is the denser medium? Out of glass and water, which is rarer and which is denser? Please answer first.
Water is rarer.
Water is rarer and glass is denser, and therefore, beta, refractive index of glass with respect to water will be more than 1. Do we understand this now? Glass is denser. Water is rarer. Okay, do we get this?
Yes, sir.
Pakka?
Pakka.
Pakka pakka? Pakka means we are done with this. So I'll just give you a minute to note this down. Anyone has any doubts up till now? This is the time that you raise your doubts. Shall I move ahead in life? Shall I move ahead? This is yes, sir. This is no, sir. This is don't know, sir. Yes?
Yes, sir.
Yes, sir.
Okay. Don't know is a very beach wala case. That's why it is like this. It is hampering like this. This is just a recollection of what we have done. Absolute refractive index, relative refractive index. In fact, absolute refractive index is also relative refractive index. The only thing is there we are comparing it with the refractive index of vacuum. Do we understand this? Everyone understands this? And here they have given the actual values of mu of glass. Mu of glass is 3/2. Remember, mu of water is 4/3. Do you understand this?
Yes, sir.
Okay. My values may not be correct. I may not know the correct values of mu. Now that takes us to what? Takes us to the laws of what? Are laws of what?
Refraction.
Laws of refraction, and that is the next heading that we are going to write, my dear friends. Laws of refraction. And to understand the laws of refraction, what we do, we draw dung, which is the boundary between two mediums, then dung. This is normal. Then dung, which is your incident ray. Angle of incidence is I. Then dung, the refracted ray. Instead of using R, I'm using T, because R has been used for reflection. So it's better not to use T. If you want, you can use R. But for me, R may create a trouble. That's why I'm using T. What are the laws of reflection, beta? Yes, what is the first law of refraction, my dear friends? Everyone knows it. Time to speak up. Huh? Say. Say. Two says. Say. Don't be shy. Don't be scared.
Sin A by sin R is equals to constant.
That is not the first law.
Reflected ray and normal lies on same plane.
That's correct. That is the first law of refraction. The incident ray, the refracted ray, and the normal all lie in the same plane. This plane, you can call it as plane of incidence, or you can call it the plane of refraction. Do you understand this? Yes, sir. No, sir. Better I go, sir. Do you understand this, sir?
Yes, sir.
Well done, sir. Now, this is what you have studied in 10th standard. Yes or no? You studied this in 10th standard. Yes or no? Tell me. Did you study this in
Yes, sir.
10th standard? Yes. Okay, sir. What's new? Remember, whatever we are doing in 12th standard is just a repetition of what we have done in the 10th standard. What I'm going to write here is this. So, ooh, 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 ooh. I've done this. I've written what I was supposed to write. Now I'd ask you to explain what I've written, and I hope all of you know this. Yes or no? Might not sound or look very unfamiliar. Do we know what I've written here? Yes or no? No, yes? Say yes, say no, say something. Do you know what
No,
I've
sir.
written here? Hmm?
Don't know, sir.
Do we understand what is this? Ding, 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 ding. Do you know what is this? These three ding, ding. Yes, sir, or no, sir? These three ding dings are unit vectors. Do we remember that first class of 11th standard way back 1 year back? Unit vector. Do we understand unit vector? Do you remember unit vector? No? Oh yes. It's a binary type of question. Either you know it or you don't know it. No or yes. This is a no. This is a yes. No. Yes. No. Yes. Which one? Or sir, beach mein. We're still floating somewhere beach mein. Either it's a no. It's not a no. It's a yes. Yes. Yes or no? Do you know it? Okay. Unit vector is a vector that gives you the direction of a vector. It's a vector in one particular direction. Now, do you remember anything? How do you find a unit vector? You divide the vector by the magnitude of the vector itself. Yes or no? Well,
Yes, sir.
okay. So that's a unit vector. And what I've written, this line, this black thing is the vector product. Yes or no? Did we do vector product there? Then there. This is the vector product. And this dot represents the scalar product. Do we remember dot product and cross product? Yes or no?
Yes, sir.
This is dot and this is cross. Now in this equation that I have written, I've used both cross and dot. So this entire thing is known as scalar triple product. This entire thing that I've written is a math term is known as a scalar triple product. Triple product, why? Because it is multiplying three vectors. The first two vectors are multiplied by cross, so I get third vector. And whatever vector I get, it is multiplied by dot. Do we understand this?
Yes,
And the
sir.
final result is a scalar, and therefore it is known as scalar triple product. And remember, whenever three vectors are coplanar, they lie in the same plane, the scalar triple product becomes 0. Can you remember this?
Yes, sir.
So this is the 12th standard way of writing the first law of refraction. I could have written the law of reflection also like this, but I do not want it because that was the very first classes. And if I would written like this, you would have gone, "Ooh, what has happened?" So that's why I have delayed it and I've used it here in the laws of reflection. What is the second law, my dear friends? Say. Don't be shy. Say.
Mu1 sin I is equal to mu2 sin R.
Mu1.
Sin I is equal to mu2 sin R.
Okay, well done. So that is known as the Snell's law. Everyone knows Snell's law, yes or no?
Yes, sir.
Well done. So it basically says that refractive index of 2 with respect to 1, which is nothing but mu2 by mu1, is nothing but
Sin I by sin R.
I by sin I write it R, I write T transmission. Do we understand this?
Yes, sir.
Instead of R, I'm using T because R is used for reflection, so I don't repeat it. This is very simple. We all know this. We all know this. So now I can write it in this way also, in the way that you said. What did you say? You said mu2 multiplied by sine of T is equal to mu1 multiplied by sine of I. Yes or no? Do you understand this?
Yes, sir.
Now remember, there is something known as the principle of reversibility of light ray. Do you understand the meaning of principles of reversibility of light ray? We have also seen it once. What does that principle of reversibility of light ray says? And you remember that mirror, plane mirror, curved mirror. I told you the light which is moving parallel to principal axis, after refraction, it will pass through the focus. Yes or no?
Yes,
Light
sir.
which is parallel to principal axis will pass through focus. If I reverse it, a light which is passing through the focus will become parallel. Yes or no?
Yes, sir.
That was nothing but the principle of reversibility of light rays. Do we understand this?
Yes, sir.
Now, if you look at the diagram, that I have drawn here, now see, in this diagram, the blue ray is the incident ray. Do we see this?
Yes, sir.
And this pink ray is the refracted ray. Yes or no? I can reverse it. That means I can make pink ray as the incident ray. So instead of it going like this, it will go like this. Do we understand this?
Yes, sir.
Then the blue ray, instead of it being the incident ray, will now become the refracted ray. Yes or no?
Yes, sir.
Now, what I have done here is this I is the angle of incidence in medium 1, and this T is the angle of refraction in medium 2. But if I reverse the light ray, T becomes the incident angle in medium 2, and I becomes the refracted angle in medium 1. Yes or no? So basically that means is I can call I as the angle of incidence in first medium, and I can also call T as, instead of angle of refraction, I can call it angle of incidence in the second medium if the ray would have gone from second to first. Do we understand this?
Yes, sir.
So instead of writing it like this, mu2 into sine T is mu1 into sine R. I can write it like this. Oops, wrong color, and I hate using wrong colors. I can write like this: mu multiplied by sine of I is a constant. Do we understand this? So you multiply the mu of the medium and you multiply it by the sine of the angle that it makes with normal, that mu into I will be constant. Yes or no? So either you call it in this way, or you call it in this way, or you call it in this way. You are referring to the same thing. Yes or no? Yes or no?
Yes, sir.
So now, putting everything together, that is what I'm going to write as the last thing. We started with mu of 2 with respect to 1. That is equal to mu2 by mu1. I wrote it as V1 by V2. I wrote it as V1 by V2. Then I wrote it as lambda 1 by lambda 2. Then I wrote it as sine I by sine E. Yes or no? So basically, when I had written them like this, always I had done the same thing. I had referred to the Snell's law. Do we understand this? Do we understand this, bacha? When I written all this, we had referred to the Snell's law, or I could write this in different way. I can write it like this: mu into V is a constant. When I write it like this, I am referring to Snell's law. This is Snell's law. If I write it like this, mu into V is a constant. Again, I am referring to the Snell's law. This means this is Snell's law. If I write it like this, mu into sine I is a constant. This is again referring to the Snell's law. Do we all understand this?
Yes, sir.
The toughest question ever to come in an IIT-JEE was in the year of 1995, and that was based on this concept. where light was entering a medium with variable refractive index. That question has come many times in many JEEs. We will do that question also when time comes. This is all about this class that we had to discuss. What we have discussed in this class is we have seen what do you mean by a rarer medium in which the speed of light is more, denser medium speed of light is less, rarer means refractive index is less, denser means refractive index is more, the speed of light is more, rarer, speed of light is less, denser. Then we have seen relation between mu and v, mu into v is constant, mu into lambda is constant, mu into sin is constant. We have seen laws of refraction. We had seen the first form of law of refraction. We have seen the first law, and I had written it in the vector form. The second law can also be written in the vector form, and that we will see in the next class. So see you there. Take care. Have a nice day. If you have
Sir.
any, you can always come up to me.
Hello, sir.
Yes, beta.
Sir, do you have sheet?
I don't understand your question, beta.
Sir, I have a doubt in the sheet.
Okay, we'll discuss that out. Don't worry. Take care.